a very important problem from your exercise of pair of straight line, that is from two-dimensional geometry. And the problem is so that the distance from the origin to the orthocenter of the triangle formed by the straight lines x by alpha plus y by beta, this is equal to 1, and ax square plus 2hxy plus by square, this is equal to 0, is given by this result. Okay, so we have to prove the distance of the orthocenter of the triangle from the origin is given by this, and triangle is formed by three straight lines. This is given by 2 and this is another one straight line. Okay, now we draw a rough sketch of the given problem, and we know that this homogeneous equation of second degree represent two straight line passes through the origin. Let it be the first be y, this is equal to m1x, and second be y, this is equal to m2x. Let it be 1 and it be 2, and then we know from the theorem of pair of straight line, we directly here write m1 plus m2, this is equal to minus 2h by b, and m1 m2, this is equal to a by b, and these two together named as relation number 3. Okay, here y equal to m1x, this is the line, first line, and y equal to m2x, this is the second line. This is y equal to m1x, and this is y equal to m2x, right? And now we draw the line x by alpha plus y by beta, this is equal to 1. Let it be this. This is x by alpha plus y by beta, this is equal to 1. Okay, and let this is origin, and this is a, and this is b. Now we first understand the definition of orthocenter. What is the definition of orthocenter? If for any triangle ABC, if we draw the perpendicular from the vertex to the opposite side, then three perpendicular meet at a point, that is concurrent, and this point is said to be orthocenter of the triangle, right? Now we first draw the perpendicular line from O on AB. This is the perpendicular line. Now we draw the perpendicular line from A to OB. This is another perpendicular line, and obviously the third perpendicular line passes through this point. Let this is the orthocenter, and let it be H, and its coordinate be P, Q. Okay, here orthocenter H, this is P, Q. Now we first find the point of intersection of the line this, and we name this line, this is x by alpha plus y by beta, this is equal to 1. Let it be relation number 4. Point of intersection of 4 and 1. So we want to find this point of intersection, that is the coordinate of A. To find the coordinate of A, we solve 1 and 4. From 1 and 4, we get, we put y equal to m1x here, and getting the value as x by alpha plus m1x by beta, this is equal to 1. So obviously x, this is equal to 1 by alpha plus m1 by beta. Okay, and then from 1 we write y, this is equal to m1 by 1 by alpha plus m1 by beta, and the point of intersection is 1 by alpha plus m1 by beta, comma m1 by 1 by alpha plus m1 by beta. Okay, this is the point of intersection of A. Now the line OP is perpendicular to AB. So the slope of OH is equal to, slope of OH is equal to obviously Q by P, because we say that or let that this is the point PQ and it be the orthocenter. We let it. Okay. So the slope of the line OH is equal to Q by P. Now the slope of the line 4. Slope of the line 4 is obviously Y. This is equal to minus beta by alpha into x to something. So we write here only slope. Slope of 4 is this equal to minus beta by alpha. Okay. Now since AB is perpendicular to OH, then we get this slope into this slope is equal to minus 1, because two lines are perpendicular. So we get Q by P into minus beta by alpha. This is equal to minus 1. That is beta by P. This is equal to alpha by Q. This is equal to, this is equal to, and we get from here, this is P by beta is equal to alpha by, this is Q by alpha. This is equal to K sec, right? We get the relation P by beta, this is equal to Q by alpha, this is equal to K. We say this is equal to K here, and let it be relation number 5. Okay. Now AH, this is also perpendicular to OB, and we know that the slope of OB is M2, but we have to find the slope of AH. The slope of AH is given by this is M1 by 1 by alpha plus M1 by beta minus Q. This is Y2 minus Y1 by 1 by alpha plus M1 by beta minus, this is P. This is X2 minus X1. This is the slope of the line AH. And now since AH is perpendicular to OB, so we get this into M2. This is equal to minus 1. Okay. And calculating this result, we get M1 minus Q by alpha minus M1 Q by beta into M2. This is equal to, if we multiply this and this, we get P into 1 by alpha plus M1 by beta minus 1. Okay, this is the right side. Now we taking common M1 first from this two term, and we get M1 into M2 into 1 minus Q by beta plus, this is minus Q M2 by alpha, and in the right side we get P by alpha plus P by beta into M1 minus 1. Okay, and we put the value of M1 M2, and which is M1 M2, this is A by B. So we put here, this is not A by 2, this is A by B, and this is A by B into 1 minus Q by beta, and in the right side we get P by alpha plus, this is P by beta into M1 plus Q by alpha into M2 minus 1. Now we use this result, that is result number 5. We put the value of P, this is equal to beta K, and value of Q, this is equal to alpha K, and getting the result as P by alpha plus, what is the value of P? The value of P is beta K, so we get this is M1 plus value of Q, this is equal to alpha K, so this is M2 into K minus 1. Okay, and now put the value of M1 plus M2. What is m1 plus m2? This is minus 2h by b. So get the result as p by alpha minus 2h by b into k minus 1. Now in the left side there be 1q and in the right side there be 1p. We also put the value of p, this is equal to k beta, and q, this is equal to k alpha here and here also, and get the result as we write here, this is a by b into 1 minus, this is q, so q means alpha k, so alpha by beta into k, and the right side is p by alpha, this is given by k beta by alpha. We write it on the left side, this is p, this is equal to beta by alpha, so k into beta by alpha, and in the left side there be remaining two term, this is minus 2h by b into k minus 1. In this relation there be three term containing k, this term and this term, and another two is 3 from k. We write 3 term in the left side. The first term is minus a by b into alpha by beta, and the second term is minus beta by alpha, and this term is, we write it in the first because this is plus 2h by b. Okay, 2h by b, and we take common k, and in the right side there will be minus a by b minus 1. Now calculating k, this is equal to, this is given by a plus b, and this is given by, we multiply here with a minus and we get, this is b beta square plus a alpha square minus 2h alpha beta. This is equal to, sorry, there is nothing to write. Okay, so we get the value of k, this is equal to a plus b by a alpha square plus b beta square minus 2h alpha beta. Now by putting the value of the k in the relation number 5, we get the value of p, this is equal to p, this is equal to k into beta, and this is equal to q, this is equal to k into alpha. And now we have to find the distance from the origin to the orthocenter. That is, we have to find the value of the distance OH. Now OH is given by root under p square plus q square. Okay, because this is the origin 0 0. And now putting the value of p and q, we get, this is k square beta square plus k square alpha square. So we get root under alpha square plus beta square into k. And what is the value of k? This is the value of k. So we put here a plus b by a alpha square minus 2h alpha beta plus b beta square. Okay, so OH is given by a plus b into root under alpha square plus beta square by a alpha square minus 2h alpha beta plus b beta square. Okay, but I make a small mistake here. When I find the value of k, here the LCM is alpha beta, we multiply here with alpha beta, then this is the correct value of k, and we put the correct value of k here, this is a plus b into alpha beta, so the answer is this, alpha beta into a plus b into root under alpha square plus beta square by this. Okay, and this is our required problem. So this is the distance from the origin to the orthocenter. Okay, very interesting problem of pair of straight line. Thank you for watching.